Here we have a very basic program which draws a square, and we can see it in action. Now, if every time we wanted to draw a square we had to write all this code, that would be a little bit upsetting. We certainly don't want to do that. As programmers, we want to be a little bit smartly lazy. We want to have the maximum effect for the least possible effort. That's efficiency. So what we're going to do is introduce a subroutine. Traditionally, for a program, it doesn't have to be for Small Basic, subroutines go at the top, and we're going to make a subroutine to make a square. So I'm going to type in sub, and if I just type in SU, I can actually complete this like this. So it's sub to begin the subroutine, end sub to end it, and we give it a name. Now I can call it anything I like, but it's going to draw a square, so I'm going to call it square, just like that. And what I'm going to do is I'm going to take my code for creating a square, and I'm going to cut it, and I'm going to paste it. Tab it across so it looks like the for loop is inside the subroutine. And if I run my program at the moment, you'll find it does precisely nothing. That's because a subroutine is a set of instructions we're asking the computer to remember. So I've said subsquare, this is a subroutine, and this computer are the instructions for making a square. Very interesting, says the computer, but it doesn't actually go away and do it. In the same way as if I presented you with a recipe and said, here's a recipe to make a carrot cake, it doesn't mean you make me a carrot cake. If I give you the recipe and then say, make me a carrot cake, please, having some manners, then you would probably make me a carrot cake. And I could ask again and again and again for the carrot cake, and I would not have to give the instructions a second or third or fourth or 200 millionth time. So to actually tell the computer to call this subroutine, we have to make a subroutine call square. Like this, and it has two brackets after it, like that. So far, so good. We have done that, but we don't seem to be much better off than before. But actually, if I say turtle.move and let's move with by 100, I can then say, well, I'd like a square here, please. And what we find is it draws a square, it moves 100, and then draws another square. In fact, I can use this inside a loop, so I can say for I is set to 1, 2, 4, draw a square, and turtle dot turn, and we're going to turn 90, end 4. And this will draw me a perfectly acceptable window. There we are. Nice and easy. So really, when we're doing this, it's doing two things. First of all, it means we don't need to repeat this code here multiple times in our program. Secondly, we are splitting our code into sort of smaller programs. You could think of this as a tiny program. Now, if you wanted a subroutine to draw a triangle, very easily, we can copy this, paste it. Let's call it triangle. And then I'm going to 3 for 3 sides, and the exterior angle of a triangle is 120 degrees. So now, if I want to, I can change my routine down here to draw a triangle, like so. And it will draw 4 triangles like that. So, what we've got is a nice little way of breaking up our design. Now, if we were to make a house, I would have thought we'd probably want to break it into subroutines called things like window, door, doorknob, roof, that kind of thing. But how you do it is up to you. What that then means is you can test the individual subroutines, and then you can have a main program down at the bottom which shows you how to run that. It shows you how to move between those different constituent parts of your house. If you are using subroutines and for loops and you produce me a detailed design for a house, I will consider that as being a fantastic achievement, and there's a few more skills we could learn, but really we're doing very well indeed. I hope the video was helpful.